So now that we have our surface, let's create the paneling of our facade by converting that surface into a mesh. This will apply a regular grid to the surface and give us a series of mesh faces which will represent the individual components of the facade. So starting with the surface, I'm going to go into the Mesh toolbar, Utilities, and select the Mesh Surface node. The Mesh Surface node will take in a simple NURBS surface, and it's going to subdivide it in the U and V direction according to inputs. So if I click on this and drag it out, I can connect my resulting extrusion surface to the S input, which is expecting a surface geometry. Here you see the U and the V inputs, so right now they're both set to 5, and it's creating 5 faces in both the U and the V direction. So now I can create 2 sliders, which will control this U and V parameter. And the shortcut for creating sliders is if you double click on the canvas, you can actually type in a number. So here I'll type in 10 as an integer, whole number, and hit enter. And this will automatically create a slider starting at 0 with that number contained in it. So if I do 10, it'll create a slider from 0 to 10. Now if I do 20, it's actually going to create a slider from 0 to 100 because it always rounds up to the nearest power of 10. I'm going to take this slider and plug it into the U input. And now the slider is controlling the number of divisions vertically in my facade. I'm going to copy it and paste the slider and plug it into my V input. So now I have 2 sliders which are controlling the subdivision of my surface. So this mesh represents my panelized surface, but I can't do much with it as a mesh. What I actually want is to extract the boundaries of each face and use those as a frame of each facade component. So Grasshopper has a series of components that help you work with different elements within a mesh. The first one I'll use is the face boundaries node. I'm going to create that here. Face boundaries will take in a mesh, and then in the output it's going to give me a polyline curve which describes the boundary of each mesh face, and this will be the frames of our facade. So now that I have these boundaries, I can try to scale them to basically shrink these windows and create an offset for the frames of the facade. For a lot of the transformation, like move and scale commands, you can go to transform menu up here, and you can find the scale in the affine transformations, and there's a basic scale component here. The scale component will take in 3 inputs. The first is the geometry, so I'll plug in the face boundaries here. And then there's a center for scaling and a factor. So you can see that previously, every time I plugged in one component to another, it had a solid single line. But now when I plug in the boundaries, I get this double line. And the double line represents the fact that there's more than one element being transferred here. Whereas before I have one mesh being translated into the boundaries node, here I have actually 49 different boundaries, one for each face of the mesh. And I'm sending all of those boundaries into the geometry input of the scale node. And the way that this works by default is that the scale node will run one time for each boundary or each geometry that's input into the node. So if my output contains 49 polyline curves in a list and they get sent here, the scale node will run 49 times. And for the other 2 inputs, I can either send one piece of information that will apply each of the 49 times that the node is run, or I can send a list of values that match the length of the list of geometries, and it's going to go step by step through the list and apply each value to each geometry in the list. So right now I have 49 geometries, but I'm actually using the same center and the same factor for scaling. So each of these frames is being scaled relative to the origin, and it's getting scaled by a factor of 0.5. So it's shrinking by 2, and what we get is actually just a shrunken version of the whole facade, which is not exactly what we want. What we want is to shrink each of these borders relative to the center of the mesh face. And I can get these mesh face centers by going to the mesh toolbar and in analysis, click on the face normals node. So this works similar to the face boundaries node. You plug in a mesh into the input, and in the output it gives you the center of each mesh face and the vector of the normal at that point. So the normal is the vector that is perpendicular to that mesh face. And you can see that the output of this node is also a list of 49 values because there's one value for each face in the mesh. So now I can plug in the center for each mesh face into the center of scaling. And now I have what I wanted. Basically, each boundary is scaled relative to each center. So by default, this node will run 49 times, and it's going to match up the two lists as it goes along. Now for my factor parameter, I can make a new slider, which goes from 0 to 1, and that will allow me to control how much each boundary is scaling. Now to create the frames of the facade elements, I'm going to actually move each of these scaled boundaries away from the facade surface in the direction of the normal vector from each mesh face. So to move these geometries, I'm going to go back to the transform menu, and in Euclidean select the move node. Here it's expecting the geometry that I want moved, so I'm going to plug in my scaled frames. And the T input is expecting a translation vector which specifies the direction and distance that the geometry should be moved. And for that, I'm going to just plug in directly normal vector for each face. So now each boundary curve is moving according to the direction of the surface, but in this case the surface is actually pointing inside, and we want those boundary curves to move outside. So to do that, we can actually go to the vector menu, and in the vector nodes, we can use the amplitude node, which takes in a vector as well as an amplitude. So here we can take in any vector and assign it the magnitude that we want. Because we know that the normals are flipped, I can make a slider, and here I'm going to set the minimum value to -5. This will allow me to set negative values, and if I plug that into amplitude and then plug the resulting vector into the translation vector input, now I can set exactly how far those boundary curves should be offset. So you can see now as we're adding nodes, all the geometry that we created before is still staying in place. So in Grasshopper, there's no such thing as an actual move command like you would find in Rhino. You're always making copies of geometry. Whatever was in the node before stays there, so we have these scaled geometries here. And when we move them, it actually creates new geometry at the specified move distance. So in this case, we might want to hide those geometries so they don't get in the way. The last thing I need to do to create the frames of my facade is to loft between the original boundary of each facade face and the new scaled and moved boundary curve. To do that, I can search for the loft node. I can also find it in surface freeform loft. And loft will take a list of curve elements and create a lofted surface through them. So to see how this works, we can actually plug in the list of scaled and moved faces And we can see here what happens. It actually takes in that list and lofts this huge surface through all of the different faces. So this is definitely not what we want. And what we need is actually separate surfaces, just taking in 2 curves at a time. And this is where list management comes in. We basically need to manage the way that both the original boundary curves and the new moved boundary curves are entering this input and are being processed through this loft node. And to do that, we're going to use the graphed node. You can search for graphed, and it's going to give you this graphed tree node. We're going to plug in our face boundary geometry into the input of that graph node. So here we see our basic list of 49 curves. And if we hover over the output, we see that now we have this new data structure, which actually has 49 individual sets, which have one geometry within each set. To visualize the difference between these 2 sets of data, we can use the parameter viewer node in the utilities of the parameters tab. This will give us a window that we can plug data into, which will visualize how that data is organized. So if we plug the face boundaries data in there, we see it has one set with 49 items. If we plug in the grafted version, we see it has 49 branches or sets with one item each. We can also double click on the parameter viewer, and here it shows the 2 levels of the data structure. The dark lines are the branches or sets, and the red lines with the orange nodes are the actual pieces of data in the branches. So if we plug in our basic list again, we see that there's only one branch. If we plug in the grafted version, we see that there's now 49 different branches. And these branches or sets is what allows us to split our data and to manage how it's being processed by this loft node. And what we want to do is basically graft both our initial boundary curves and our moved boundary curves, and then merge them so that we have 49 different branches or data sets, which each contain 2 curves, one representing the original boundary and one representing the moved boundary. To do the merge, I'll use the merge node, and this lets us take in any number of data sets and merge them into a single one. If I zoom in on this node, you'll see it pops up with some pluses and minuses. This lets us basically manage the amount of inputs. Because merge will take in any number of data sets, we can actually set the amount of data sets we're using here. So in this case, I'll plug in our grafted data set here. You can see when we graph the data set to create this 2-dimensional structure, the line changes from a double line to a double dashed line. And this tells us that not only are we working with multiple pieces of data, but they're actually organized in this more complex data structure. So right now, merge is just outputting the same data set. We can plug in our moved frames, and if we hover over the output, we see that we now have different branches, but one branch has 49 elements and the others have 1 element each. And this is because this data set is still not grafted. So we can create a new graph node and pass this data through it, but Grasshopper actually has some shortcuts. If you right click over any output or input, it allows you to do some basic operations such as grafting directly on that input or output. So we can do the graft here at the output or here at the input into the merge node. So I'll just graph that here. So we're passing a flat list, but when it hits the merge input, it's actually going to be grafted into this branch structure. Now if we hover over the output, we see we have 49 different branches, and each branch contains 2 curves because it's combined those 2 data sets together. And now if we pass the resulting data set into the loft node, we get the desired outcome because it's taken each branch and is performing the loft on the 2 curves within each branch of the data set. So it's running 49 times, and each time creating a single surface, which is specified by 2 input curves. So you can see our lofted geometry here of the facade frames. We can still control everything about this geometry through our inputs, so we can control the depth of the offset, control the scale factor, as well as the resolution of the whole facade. We can also control the shape of the facade by going back to our Rhino window, selecting the original input curve, turning the points on, and moving the control point. So I can change the shape of the whole facade and everything stays together. So as you're working with Grasshopper, you might have noticed that you can't actually select any of the Grasshopper geometry within your Rhino window. This is because all this geometry is not actually physical Rhino geometry. It's virtual geometry that's being constantly generated and visualized through this Grasshopper workflow. You can control what geometry is visualized with these buttons in the Grasshopper interface. You can hide all the geometry, you can visualize it as a wireframe, or you can show it as shaded surfaces. This button allows you to visualize only the geometry that you have selected, which sometimes helps you focus on specific parts of your definition. If you want to physically create any of the geometry that you're making in Grasshopper in Rhino, you can do that through a process called baking. And what baking will do is it'll take any of the geometry stored in any of these nodes, and it will recreate the geometry as physical objects within the Rhino interface. To do that, I can either click on the node and right-click. This will bring up a series of shortcuts, and I can hit the bake icon here, or I can right-click on any node and go to bake. That will bring up a series of options which lets me select the layer I want to create the geometry on. I can just keep the defaults and click OK. You can see now it's baked in, or it's created all these surfaces as actual surfaces in Rhino. So if I hide Grasshopper visualization here, I can select all the surfaces. I can work with them just like any object in Rhino. It's important to remember though that as soon as you bake something, all of the parametric relationships that created the geometry in Grasshopper are now gone. So for instance, right now the Grasshopper and the Rhino geometry are overlapping, but if I change anything about how this works, you can see that they're no longer lined up. So now that I have this definition, I can actually apply it as a system to new geometries. So right now we're using this input curve to create the whole facade. I can now create other curves. So for instance, I can maybe make a circle, and I can replace this input now with this new curve by right-clicking on the geometry node, going set one geometry, and clicking on the circle. You can see now that the same facade applies as a system to this new curve. If I don't want to work with just extruded surfaces, I can also rework this definition to accept any surface directly from Rhino. So maybe I'll start with the same idea. I'll take this input curve, and now in Rhino, I'll use the extrude command to create a surface, and then I'll explode that surface so that it's no longer an extrusion, but a simple open surface. I'll use the rebuild command. Now I'll rebuild that surface with 5 control points along the U and the V, and 2-degree curvature in both directions. Click OK. I can hit F10 to show the control points. And I can change the overall shape of the surface. Now I can create a new geometry node to store the reference to the surface. So I'll just type in geo and click the geometry node. I'll reference the new surface into this geometry node. And now I'm going to replace the extrusion geometry that I created in Grasshopper with my new reference surface by just dragging a line into the input, which will actually replace this input here. You can see that my new surface has a different orientation than the extrusion. So I can use the amplitude slider to actually flip the extrusion geometry back to the right side. So now I have a different level of control. Instead of just having a curve, I can shape the surface as I want. And my facade geometry stays completely parametric. Once I'm happy with it, I can go back to my loft, right click, hit bake, and now I have my facade elements as actual geometry in Rhino.